I'm going to start with a typical software problem. We do a lot of work with software companies, small and big and very big. And this is a problem that we see all the time. And I mean, I'm going to take this perspective that you've developed a successful software system already, or you inherit such software. But there are also other perspectives where you can use the same approach. But that's the story I'm going to tell today. So you have this software system and successful, so therefore users ask for more functionality all the time. And it might be that the original software developers for the software system are gone. They might still be in the organization, but they might be busy with other stuff, so it's not so easy to access them. So this and many other circumstances make it often very difficult for the developers or maintainers of that software to fully understand the software itself. For example, where is the architecture in the code? Let me explain that. There might be what we talk about a planned architecture or a mental model of the architecture, which means that the architectures or the lead developers, they have some kind of one view of the system. They might talk in terms of, oh, I have these 3 layers and I use this design pattern or architecture style to make the software flexible in this way, or to accommodate for future changes and things like that. But often those kinds of architectures or architectural features are not so easy to find in the code. And therefore, it makes it kind of difficult also to understand what are those consequences from changes. What seems to be like a small change might not necessarily be a small change, might actually be kind of a big change, but it's very difficult to tell. And in addition to this, as you change the software, I mean, people don't have a lot of time to kind of bridge that gap between the mental model of the architecture, or the planned architecture, or the documented architecture, and what's actually implemented in the code. There's no time to go back and update that. So over time, as you make more changes, actually the software becomes even more difficult to enhance, maintain, and test, and what have you. So it's an increasing problem. And this is an issue that we are researching. And you might ask, so why are we researching this? Well, actually, Fraunhofer develops a fair amount of software. We actually do distributed software development with our sister institute in Kaiserslautern, Germany. And we often have people visiting us. And they come here for a shorter period of time. They come for 6 months or so. And what we typically try to do is to hand them a component to develop. And they go away for some time and then come back and say, look here, Michael, it works. And I can kind of easily tell that this component, it does work. But there's seldom any time to immediately look into how it was implemented. And of course, I had this mental model of the architecture in mind, and I expected them to put the new component, you know, in the correct layers and in the right places. And then these people disappear, and sometime afterwards, we have to maintain what they developed for us. And that's when we really have time to look into this component. And often it's like, oh my God, how was this implemented? It doesn't follow our architecture at all. It violates all those nice layers and other architectural constructs that we spent a lot of time building into the software. So we end up in a very difficult situation. So we decided many years ago to try to address this problem, and so that's really how the SAVE approach started developing. And since then, the approach has kind of matured over time, and we have applied it to many other software systems also. So that's the story I'm going to tell today. There we are. Okay, so this slide is called redesign as a one-time solution. So say that you have that situation, that you have had people developing software for you, and now you have this software, but at some point it's impossible to continue changing the software. We say that the code has degenerated. It's a lot harder to maintain and change than it should be. So the possible solution here is a lot of people end up with, after some time, is to restructure or redesign or refactor the software. You can call it whatever you want, but essentially what it means is that you have to go over the software and kind of reorganize it and make it better. This is kind of tricky because obviously you don't end any end user functionality, so it's kind of difficult to get management to buy into this. But you might get there. If it's difficult, you have enough pain, then you can get to do this. And if it's from an overall software perspective, maybe you want to make it easier to add new components. Or if it's one component that's really messed up and you need to clean it, you might want to use some design patterns to improve the design. But the bottom line is that however you do it, it's kind of a big investment. And there's a lot of pain actually involved. So the questions people ask themselves is that, okay, so I've done this work. How do I protect the investment? How do I keep this code from degenerating in the future? So this is really a one-time solution, so I don't have to do this redesign again. So that's where we're getting into how can I create a more sustainable solution to avoid these problems in the long run. So we come up with 3 steps that we believe kind of address this issue. The first one is, of course, I mean, these are very common sense, to define and document the architecture. You want to document the goals, the design rationale, why you built it in a certain way, why it's important to follow it, and so forth. But we all know that just because you wrote something doesn't mean that people will actually read this information. So you also have to communicate the architecture. You have to explicitly inform everybody involved, including the programmers, of course, what really is expected. What I mean by that is that you really have to explain that, look here, I put this mediated design pattern in here to make it easy to add new components. Therefore, you're not allowed to mess with it. You have to stick to this design pattern and do it this way. Otherwise, you violate the goals. But, I mean, just telling people what to do is not enough also. So what we also have come up with that you have to kind of review each change. You have to have someone, best would be, of course, an architect, who kind of takes this overall perspective, really cares for the architecture of the system and really reviews each change and makes sure that everything is implemented according to the plan, so that no one gets a chance to violate all these architecture features. And you really want to use the architecture as a guide to find flaws. Now, here's the problem also. How do you do that? How do you review each change? And this is really where we had a little bit of a problem, because there wasn't enough time to do this. So that's why we started creating this SAVE approach. And it really supports this process. So this software architecture visualization and evaluation